In this video, we are going to look at relations. So first we start over the definition of a relation, which is a relation is a set of ordered pairs. So I'm going to have a relation is a set of ordered pairs. And of course, I'll give an example of that. So we're saying here that a relation is a set. So we're going to have the curly brackets for a set. Then we are saying it's a set of ordered pairs. So ordered mean order is important and pairs mean two. So I'll give my first example of an ordered pair. So I'll have 1, 3. Then my next ordered pair, I'll put 2, 4. Then I'll have 3, 5, 4, 6, and 5, 7. All right, so this is an example of a set. So you see curly brackets, a set of ordered. Order is important, so that means if I have 1 first, then 3, that's something different from having 3 first, then 1. And pair means 2, so 1, 3 is a pair. Therefore, I have a set of ordered pairs. So I'll just emphasize on the point that order is important. So I'll write that 1, 3 is not equal to 3, 1. So that means although they are the same numbers, I can't just switch them around and they'll mean the same thing. If I switch them around, it's two different things. Therefore, order is important. Now, within this set of ordered pairs, the set of first values, so that's the 1, the 2 here, the 3, the 4, and the 5, I'll just shade it and highlight it. So the 1, the 2, the 3, the 4, and the 5, those will be a set of first values, and those will be members of the domain. So I'm going to write that a set of first values are members of the domain. All right, example, my domain is equal to, so it's a set, all right? And I'm just taking the set of first values, so that will be the 1, the 2, the 3, the 4, and the 5. All right, so those are the things that I shaded in blue. Those are the numbers that came first in your ordered pairs. Now, if you look at the set of second values, so that'll be the 3, the 4, the 5, the 6, and the 7. Those are the second values, right? Because the 1 comes first, that's first, then the 3 comes second. So the second values. So the set of second values are members of the range. So I write that the set of second values are members of the range. So example, I have range is equal to, and I have my set, which will be 3, 4, 5, 6, and 7. All right, so we have 3, 4, 5, 6, and 7. Now, these set of first values that are members of the domain are known as X values. So the 1, 2, 3, 4, and 5 are known as X values. All right, so that's X here, X. Okay. So I'll write that the members of the domain are X values. Okay, and the set of second values, which are members of the range, those are Y values. All right, so I put Y here, here, here. And I'll write the members of the range are Y values. So the next thing that we're going to have is that a relation can be represented on a mapping diagram or on a graph. So I'm going to write that a relation can be represented on a mapping diagram or on a graph. All right, so now I'll go to the next page and I'll draw a mapping diagram and also the graph. And I'll do that for the same relation here, the same set of ordered pairs. All right, so here I wrote back my relation, which is the set of ordered pairs with the 1, 3, 2, 4, 3, 5, 4, 6, and 5, 7. So now I'm going to do the mapping diagram. So I'll write out the members of the domain. And my domain are all the X values, which is a set of first values. So my domain is equal to 1, 2, 3, 4, and 5. And my range is set of second values, which are the Y values. So my range would be the 3, the 4, the 5, the 6, and the 7. All right, so what I have here is my domain, the set of x values. So let's write a little x down here, the x values. And then I have my range here, which is set at y values. So let's put y down here. Now what I'll do is look at my set of ordered pairs, all right, and see that 1 is mapped to 3. So I'll put an arrow connecting 1 to 3. All right, so here I have my arrow connecting 1 to 3. So this means 1 is mapped to 3, and that lines up with the ordered pair. This x value 1 is mapped to this y value 3. This member of the domain is mapped to this member of the range. So they have a domain mapped to range, 1 mapped to 3. So you're going to do the same thing for all the other ordered pairs. So 2 is going to be mapped to 4. So I'm going to have this arrow here where 2 is mapped to 4. Then you're going to have 3 is mapped to 5. So 3 in the domain, mapped to 5 in the range. So I'm going to have this arrow here, 3 in the domain, mapped to 5 in the range, and so on. 4 mapped to 6. All right, so here I have my arrow mapping 4 in the domain to 6 in the range. Line up with this ordered pair here, 4 mapped to 6. And last one, 5 mapped to 7. So I have 5 in the domain mapped to 7 in the range. And this is the mapping diagram. So now I said a relation can be represented on a mapping diagram or on a graph. So now we'll draw the graph for this mapping diagram, which will be the graph for this set of ordered pairs, which is the graph for the relation. All right, so before I draw my graph, what I have here is what we call the Cartesian plane, which is two number lines intersecting at 90 degrees. So this is a vertical number line. So the top part is positive numbers and the bottom part will be negative numbers. This here is a horizontal number line. So to the right is positive numbers and to the left is negative numbers. The point of intersection of these two lines, which will be in the middle here, is what we call the origin. Now, sometimes we put O like this, and this will represent the origin, which is 0 on the x-axis. We call this the x-axis, the horizontal number line, and the vertical number line we call the y-axis. So this is 0 on the x-axis and also 0 on the y-axis. Now, remember, the y values are members of your range, and the x values are members of your domain. So the x-axis would be for your domain, and the y-axis would be for your range. Now we can look at our mapping diagram here and see 1 in the domain is mapped to 3 in the range. Or we can look at our ordered pair here and see 1 in the domain is mapped to 3 in the range. What does that mean? This is the x values here. So 1 in the domain, that's here, is mapped to 3 in the range, which is up here. 1 on the x mapped to 3 on the y. If you draw a vertical line up from 1, it would intersect with this horizontal line coming across from 3, which would be right here. And this will represent 1 in the domain mapped to 3 in the range. So likewise, we have 2 in the domain mapped to 4 in the range. Look at the ordered pair here, 2 in the domain mapped to 4 in the range. So 2 in the domain is here. We go all the way up to 4 in the range, which is right here. All right, we see 2 in the domain mapped to 4 in the range. And now you do the same thing for all the other ordered pairs. So we have 3 in the domain mapped to 5 in the range, 3 on the x mapped to 5 on the y. So you come here, 3 on the x, go all the way up to 5 on the y, which is right here. Then we have 4 on the x mapped to 6 on the y. So that's 4 here, go all the way up to 6. And then we have 5 on the x mapped to 7 on the y. So you come 5 on the x, and we go all the way up to 7. I plot those points. Now, when you're plotting points, we use an X like this to plot points, or you can use a circle with a dot in the center. So now what I'll do is take my ruler and draw a straight line connecting these points. So here I have my ruler and I'm drawing my straight line connecting all the points. And this would be my graph to represent this mapping diagram, which represents this relation, which is the set of ordered pairs. Now, one thing I want to point out about the mapping diagram is that the arrows on a mapping diagram always points from domain to range. So it doesn't necessarily mean that you always have to have the domain on the left-hand side and the range on the right-hand side. I can have it switch around where the domain is on the right-hand side and the range is on the left-hand side. As long as the arrows point from domain to range, the mapping diagram is good. I can have the domain written above and the range written below and the arrows coming down. All right. But as long as the arrows point from domain to range, the mapping diagram is good. So now we're going to look at types of relations. And as I mentioned with the mapping diagram, that the arrow always points from domain to range. So the way we name the types of relations is going to follow the same pattern, domain to range. So the first type we're going to have is a one-to-one relation. And that's going to look just like this here. This is a one-to-one relation. All right. Each member of the domain is mapped to one member of the range. The arrows just go straight across like this. One mapped to one mapped to one. All right. So this is a one-to-one relation. And this is the graph of what a one-to-one relation look like. All right. So I just brought it back here that for my one-to-one relation, this is an example of a mapping diagram. One-to-one relation, and of course the graph is a straight line. And this is exactly what we have on the other page to demonstrate our first relation. Now our next type we're going to look at is the many-to-one relation. So here I have my set of ordered pairs to represent my many-to-one relation, and now I'm going to draw a mapping diagram to represent it. All right, so what I did is I took out my set of first values, so the -2, the -1, the 0, the 1, and the 2. All right, I'll shade that. -2, -1, 0, 1, and 2. And those were my x values, or my set of first values, which are members of the domain. So therefore, I have my -2, -1, 0, 1, and 2 from here. Now for my range, I took out the set of second values, which will be the 4, the 1, this 0 here, this 1, and this 4. Now notice we have 4 occurring twice. Now because it's a set, we only write the element once. So I don't put 4 occurring twice, I write the element once. All right, we notice we have 1 here and 1 here. So 1 is occurring twice again. In a set, we don't repeat elements. So we're just going to write the 1 once. Of course, we have the 0 here, so 0 here. All right, and these members of the range are y values. So looking at our ordered pair, we have -2 in the domain is mapped to 4 in the range. So -2 in the domain is mapped to 4 in the range. All right, so I have -2 in the domain mapped to 4 in the range. Now I'll have -1 in the domain mapped to 1 in the range. So that's this -1 in the domain here mapped to 1 in the range here. All right, so I have my arrow pointed from -1 in the domain mapped to 1 in the range. Then I have 0 mapped to 0, so 0 in the domain mapped to 0 in the range. All right, so here I have my 0 in the domain mapped to 0 in the range. And notice my arrows always pointed from domain to range. Next, we'd have 1 in the domain mapped to 1 in the range. So this 1 in the domain here mapped to 1 in the range here. All right, so I have my arrow pointed from 1 in the domain here mapped to 1 in the range. And right now, you can see a little pattern here, right? We have more than 1 in the domain. This -1 and 1 mapped to this 1, which is just one member of the range. So we have many mean more than 1. So many in the domain mapped to 1 in the range. So the name takes the same direction. The many representing the domain and the 1 representing the range. So domain to range. Many in the domain to 1 in the range. And that's how you name the relation. Of course, the 0 to 0 is 1 to 1. But this -1 and +1 mapping to the same 1 here makes it a many-to-1. And likewise, this 2 is going to be mapped to 4. So we're going to have this 2 mapped to this 4 right here. And again, it's the same thing. This -2 and this +2 mapped to 4 here. So 2 members of the domain mapped to 1 member of the range. So that's many to 1. And that's how you get the name for the relation. So here I have my Cartesian plane to draw the graph for this mapping diagram, which is this many-to-1 relation. So first we're going to have -2 in the domain, map to 4 in the range. And you can see that here, -2 map to 4. So -2 go all the way up to 4. Then we're going to have -1 map to 1. So we've seen that -1 in domain, map to 1 in the range. So -1 goes all the way up to 1 here. Then we're going to have 0 map to 0. So here, 0 in the domain, map to 0 in the range, which is the origin. So that's the point of intersection of the two number lines. That's 0, 0. Then we're going to have 1 in the domain, map to 1 in the range. So that's the 1 in the domain, map to 1 in the range. So 1 goes all the way up to 1 here. And then you're going to have 2 in the domain, map to 4 in the range. That's 2 in the domain here, map to 4 in the range. So from 2 here on the X, go all the way up to 4. So obviously, these points would not give us a straight line, so we can't take our ruler and connect these points. We'll have to do this freehand and make a smooth curve connecting these points. All right, so there you have it. I drew this curve freehand, connecting all the points. And this graph would represent this set of ordered pairs, which is a many-to-one relation. Now, this is just one example of what a many-to-one relation can look like. So the graph doesn't have to be a smooth curve like this. Now, how to recognize if a graph representing a many-to-one relation is that if you were to draw a horizontal line, and that line intersects the graph at more than one point, that will represent a many-to-one relation, okay? Now, if you look here, a straight line would represent a one-to-one relation, all right? And of course, any graph that you could draw a horizontal line that would intersect the graph more than once would be a many-to-one relation. So now moving on to the one-to-many relation. All right, so here I have my set of ordered pairs to represent this example of a one-to-many relation. Now I'll draw my mapping diagram. So here I have my domain and range for this set of ordered pairs. Now notice in the domain I have 4 occurring twice. So remember, it's a set and we don't repeat elements in a set. So I'm going to write the 4 only occurring once. Then we have this 1 here in the domain and this 1. So 1 is occurring twice in the domain. So I write it only once. And of course, the 0 is in the domain. And I write the 0 here. Now my range is a set of second values, which is the -2, the 2. So I have the -2 here, this 2 here. We have -1 and 1. So -1 and 1. And then we have this 0 here in the range, 0. So first of all, we're going to have 4 mapped to -2. So 4 here in the domain, mapped to -2 in the range. All right, so I have 4 in the domain, mapped to -2 in the range. So the arrow is pointed from 4 to -2. Then I have +4 mapped to +2. So 4 in the domain mapped to +2 in the range. So that's 4 in the domain mapped to this +2 here. All right, so I have my +4 in the domain mapped to +2 in the range here. The arrow is pointed from 4 to 2. Then I'll have 1 in the domain mapped to -1 in the range. So that's 1 in the domain here mapped to -1 in the range here. All right, so I have my 1 in the domain mapped to -1 in the range. Then I'll have 1 in the domain mapped to +1 in the range. So that's this 1 in the domain here mapped to this +1 in the range here. All right, so I have my 1 in the domain mapped to this +1 in the range. And now it's just to map the 0 to the 0 here, the origin, right? 0 to 0. All right, so I have my 0 in the domain mapped to 0 in the range. Now look at how the arrows go. Again, remember, the 1 here is the domain and here's the range. So 1 in the domain must be mapped to more than 1 in the range. That's how you're going to get the one-to-many name for the relation, right? The type. So look at what we have here. We have 4, right? 1 in the domain mapped to more than 1 in the range. So that's one to many. All right? Look at it here for the 1. 1 here is mapped to -1 and also +1. So 1 in the domain is mapped to more than 1 in the range. That's why it's one to many. Of course, the 0 to 0 is a 1 to 1. So this spoils it from being a 1 to 1 to change it into a 1 to many mapping. Also, the 4 does the same thing too, right? One to many. All right, so always remember domain to range. So when you see one to many, it means one in the domain mapped to more than one in the range. All right, so here I have my Cartesian plane, which is the intersection of my two number lines at 90 degrees. So let's plot these points for this one to many relation. So we have 4 in the domain mapped to -2 in the range. So you're going to have 4 in the domain mapped to -2 in the range. So you're going to start at 4 and go all the way down to -2 in the range. Then we're going to have 4 mapped to 2, which is this 4 mapped to 2 here. Of course, the 4 to -2 was here, and now 4 to map to 2. All right? So we're going to have the same 4 in the domain mapped to 2 in the range. Then we have 1 mapped to -1. So 1 in the domain mapped to all the way down to -1 here. And then we're going to have 1 in the domain mapped to 1 in the range. So 1 in the domain here go all the way up to 1 in the range here. And then we're going to have 0 mapped to 0, which is the origin. And of course, we can't take our ruler and connect these points. We'll have to do this freehand and make a smooth curve. All right, so this is just an example of a graph that will represent a one-to-many relation. Now notice if I were to take a vertical line, it will intersect the graph more than once. So that's the way to know if a graph would represent a one-to-many relation. If you take a vertical line and it cuts the graph more than once, it's a one-to-many relation, right? Remember, if you draw a horizontal line and it cuts the graph more than once, then that is a many-to-one relation. And then if we have a straight line, that's a one-to-one relation. Okay, and the last type of relation would be a many-to-many relation. So as long as you see a one-to-many pattern, which is 1 going to many, and also a many going to 1 pattern in the same mapping diagram, that will represent a many-to-many relation. All right, so the last one is a many-to-many relation. And for this one, I wouldn't list all the set of ordered pairs or draw a graph. I'll just draw the mapping diagram. Well, an example of a mapping diagram that will represent a many-to-many relation. Now just remember, this is an example of a mapping diagram to represent a many-to-many relation. All right, so here I have A mapped to 1, so this is 1-to-1. Then I have B mapped to both 2 and 3, so this is a one-to-many. But then I have B and C mapped to 3, which is a many-to-1. So within this diagram, we are clearly seeing we have a one-to-many relation, and we also have a many-to-one relation. And that would make this a many-to-many relation. And that would bring us to the end of this video.